All right, team, listen up. Today, we're doing more than just talking theory. This is a practical workshop. We're going to build a corporate network from the ground up, one that's not just functional, but truly unbreakable. This is where you level up from technician to architect.
So picture this. You walk in Monday morning and boom, you've got a new assignment. A fast-growing company needs a rock-solid network, and you're in charge. Failure is not an option. Now, you could panic, or you could have a plan. This is exactly the kind of challenge that defines a great engineer. So let's skip the panic and get straight to the plan.
Our first big decision, and honestly the most important one, is our philosophy. We're always going to use the top-down approach. Why? It's simple. The network is there to serve the business, not the other way around. It's so easy to fall into the bottom-up trap, where you start with the coolest new gadgets, but that almost always ends with a network that's expensive and doesn't actually do what the company needs. We start with why before we even think about what.
And here's our playbook. The top-down approach gives us this clear, four-step process. First, we analyze. We talk to people. We figure out what the business and the users actually need to do their jobs. Then, we create a logical blueprint. We map it all out. Only then do we start picking out the actual hardware. And finally, we build a prototype. We test the heck out of it, and then we deploy. This process is our secret weapon.
Okay, so let's get into our architectural blueprint. You wouldn't build a skyscraper on a weak foundation, right? Of course not. For our network, that solid foundation is what we call the three-layer hierarchical model.
Take a good look at this. This right here is the gold standard for any serious enterprise network. By breaking our network into these three distinct layers, we get a system that's modular, easy to manage, and, most importantly, scalable. Each layer has a very specific job to do, which saves us from the chaos of a flat, disorganized network that's impossible to grow.
Let's break it down. At the bottom, you have the access layer. This is where all your users, their PCs, their phones, this is where they all plug in. In the middle, you have the distribution layer. Think of it as the smart traffic cop, gathering all that traffic and applying our rules. And at the top, you have the core. Its only job is to be a ridiculously fast backbone. This separation is key. It means a problem at the access layer doesn't bring the whole company down. It's how we build a stable network.
So we've got our blueprint. Now, what are we going to build it with? It's time to talk about the actual devices and, more importantly, where they fit inside our three-layer model.
Now, this right here, this is a concept that trips up a lot of new engineers. So let's nail it down. The difference between Layer 2 and Layer 3. Layer 2 is all about the local network, the LAN. It uses physical MAC addresses, and its hero device is the switch. Layer 3 is all about connecting different networks together. It uses logical IP addresses, and its main tool is the router. Getting this right is absolutely fundamental.
Let's dig a bit deeper. Switches are fantastic because they break up what we call collision domains. Basically, each port on a switch is its own little private conversation, so devices aren't all shouting over each other. But, and this is a big but, switches do not stop broadcast traffic. A broadcast is like a loudspeaker announcement to the entire building. To stop that, you need a router. Routers create hard boundaries for those broadcasts, keeping your network quiet and efficient.
Okay, quick concept check. Let's make this easy. Simplex communication, that's a one-way street, like your TV just broadcasting to you. Half duplex is a walkie-talkie. You can talk and you can listen, but you can't do both at the same time. What we want is full duplex. That's a two-lane highway, a normal phone call. Data can flow both ways at the same time.
You know, every piece of data that flies across our network is wrapped up in something called a packet. And that packet has a header. Just think of it like an envelope. The destination address tells the routers where to send it. The source address is the return address. The sequence number helps put big messages back together in the right order. And the CRC? That's kind of like a tamper-proof seal. It tells you if the message got corrupted along the way.
You know, a great network isn't just about speed. It's about resilience. It has to stay up. So now we're going to focus on how to build in that toughness by defeating the network's worst enemy, the loop, and planning for those moments when things inevitably go wrong.
Redundancy is good, right? We want backup paths in case a cable gets cut. But here's the catch. Unmanaged redundancy is a complete disaster. This is what a network loop looks like. You have multiple paths, a broadcast frame gets sent, and it just starts circling and amplifying until the entire network just melts down. And the result is pure chaos. You get a broadcast storm that eats up 100% of your bandwidth. Your switches start to lose their minds, constantly rewriting their tables about where devices are.
They see a PC on port 1, then port 5, then port 1 again. They get totally confused and just stop forwarding traffic correctly. Pretty soon, the whole thing grinds to a halt. Total network failure. So, what's the solution? It's called Spanning Tree Protocol, or STP. Think of it as a GPS for your Layer 2 network. It figures out all the possible roads, picks the best one, and then intelligently blocks the other ones to prevent any loops. But, and this is the cool part, it keeps those blocked paths on standby. If the main road ever fails, STP instantly opens up a backup route. We get our redundancy without any of the risk.
Beyond loops, our ultimate safety net is a solid backup plan. And I'm not just talking about user files here. I'm talking about our device configurations, the brains of our network. Having an automated way to back up every switch and router config is absolutely non-negotiable. When a device dies, this is the difference between a few minutes of downtime and a few hours of panic.
All right, we're in the home stretch. We've designed a network that's smart, scalable, and resilient. Now for the final polish, making sure it runs fast for our users and locking it down tight.
When a user tells you the network is slow, that's not enough information for us. We need to speak in metrics. These are the big three. Bandwidth is the top speed on the box, the theoretical maximum. Throughput is what you actually get in the real world. And latency is the delay. Knowing the difference is how you actually solve performance problems.
And here is the absolute best way to remember this. Bandwidth is the size of the water pipe. Latency is how long it takes that first drop of water to travel from one end to the other. And throughput is how much water is actually flowing out per second. You can have a massive pipe, but if the delay is huge, your actual flow is going to be terrible.
Finally, let's talk security. We have to protect this thing. Against eavesdropping, we encrypt our traffic. That's a given. For unauthorized access, it starts with the simple stuff. Lock the doors to your network closets. And, just as important, disable every single unused port on your switches. An open port is an open invitation for trouble.
So, let's wrap this up. This is your toolkit. Number 1, plan top-down. Start with the business. 2, build in layers. It's the only way to stay sane. 3, use Spanning Tree to prevent loops. And 4, don't forget to get your hands dirty. Use those crimpers and cable testers. A lot of weird network problems come down to a bad physical connection.
Look, at the end of the day, what we do is more than just plugging in cables and typing code. We build the central nervous system of the entire company. We are the backbone. Everything else depends on the work we do. So the only question left is, are you ready to build one that truly won't break?